This is Mr. Beck Does Your Homework, AP Physics, Homework 5.1, questions 13, 14, and 15. This is a great conservation of energy problem with a little bit of work involved. The block starts from rest here and slides down a frictionless track except for a small rough area on the horizontal section of the track. It leaves the track horizontally, flies through the air, and subsequently strikes the ground. The acceleration of gravity is. What is the speed of the block when it leaves the track? Well, I start off at rest up here with some potential energy. So I know that my total mechanical energy is going to be my potential energy at that first place right up here at 3.6 meters. Now, what's going to happen to that energy as it slides down? As it slides down frictionless, it's going to lose some potential energy from 3.6 meters down to 2.1 meters and gain some kinetic energy. Then I'm going to take that total amount of energy and I'm going to lose just a little bit of it as this friction does negative work on the block. So this is my total amount of energy, and then it's going to have some energy at this position right as it's leaving the table. It's going to have some energy. So that's what I want to find out, is how much energy it's got there, because some of it will be potential, the rest will be kinetic, but it lost some. So if I have my PE from my first place, and I'm going to subtract whatever work is done by friction, that's going to equal my new PE at, we'll call this my second spot, plus my kinetic energy at that second spot. So my PE at the top is mgh. The work done is going to be the force of friction times the distance that I move. The force of friction is going to be the mu times the normal force. And the normal force is going to be mass times gravity. So this is going to be wind up mgh minus mu times the normal force, which is going to be mu mg d. The mass times gravity times the distance it travels, which is going to be 1.4 meters. So that's how much work is done. It's mu times the normal force, which is the force of friction, times the distance. That's the work that I'm doing by friction. That's going to equal my new PE, which is going to be mg, my new h, I'll call that h2, that's h1, plus 1/2 mv squared, and that's the v at location 2. You'll notice mass is here and here and here and here, so all that cancels out. So I've got 9.8 times my initial height of 3.6 minus my mu, it's 0.3. G is 9.8. D is going to be my 1.4 meters. Equals G, 9.8. My height 2 is 2.1 meters. Plus 1/2 of my velocity squared. Number, solve for V equals. So that'll give me this answer to my first question. What is the horizontal distance the block travels in the air? Well, now I'm back into my equations of motion. I know this velocity, that's a horizontal velocity, so that's really Vx. What I need is that my distance traveled, x, is going to be my velocity in the x world times my time. But my time is going to be how long it takes to fall, 2.1 meters. So in my y world, I'm going to have my y distance is going to be my initial velocity times time plus 1/2 at squared. But my initial velocity in the y world is 0 because it's going horizontally. So my height of 2.1 meters is going to be 1/2 of my acceleration, which is 9.8 times my t squared. Now really this should be negative and this should be negative because it's falling down. Those negatives will cancel out, so twice that divided by 9.8, square root it, I'll get myself a time. Use that time, I'm off the page, sorry. Use that time and this velocity from up here to get my distance. So my distance is going to be this velocity times this time. That will give me how far I go. What is the total speed of the block when it hits the ground? Answer in units of meters per second. Well, now I've got a velocity here, and I want to know my final velocity here. So this velocity was when it had some potential energy and some kinetic energy, and I want to know when it hits the ground. So what I could do there is I could say, and I'll do this right here, I know that when it leaves, it's going to have some potential energy, mgh, and that's my height at point 2, plus some kinetic energy, 1/2 mv squared. And then when it hits the ground, it's all going to be kinetic energy, so it's going to be 1/2 mv squared. So this is my velocity at 2. This we'll call velocity at 3, I guess. So this point I'll call 3. So now my mg height 2, again, mass cancels out, so I don't care about that. So I'm going to have gh 1/2 v squared, 1/2 v squared. So this is going to be my g of 9.8. This is my height 2, which is 2.1 meters for me, plus 1/2 of v2 squared. That's this one. This is this velocity squared. So I'll just call that v2 squared equals 1/2 of v3 squared. And you can solve for this velocity by plugging your nose and working it.